Students, in this video we will learn about the Ohm's law. To understand the Ohm's law, consider about the relation between potential difference and current flowing through the conductor. When potential difference is applied across the terminals of the conductor, their current is flowing through the conductor. Okay, consider about this conductor made of atom, and here consider about this atom. At room temperature, this electron revolving in the outermost orbit of the atom, here this atom gets some extra energy, thermal energy, and if this thermal energy is more than that of the attraction force of this nucleus, then this electron is detached from the atom and free to move in the conductor. Okay, now inside the conductor, the free electrons, the number of free electrons is very huge amount. Now these free electrons are moving in zigzag motion, and the average thermal velocity of electrons is 0. Average thermal velocity is 0 means here no electric current is flowing. Now an external potential difference is applied across the terminals of the conductor. This end of the conductor is connected to the positive terminal. That's why in this phase of the conductor, here positive potential is developed. This end is connected to the negative terminal. That's why here negative potential will be developed. Due to the potential difference, here electric field is produced. And what is this electric field? The formula of electric field is E equal F upon Q. Actually, the electric field is force per unit charge. Here charge are electrons. That's why here electric field is actually force. So all free electrons experience some force towards the positive phase of the conductor. That's why all electrons are drifted towards the positive phase of the conductor. Okay, and electrons are charged particles. That's why charge is flowing towards the positive phase. Okay, and you know that the charge flowing per unit time is called current. That's why through the conductor current is flowing when potential difference is applied across the terminals. And the direction of current is opposite to the direction of electrons. So the direction of electrons is the motion of the direction of motion of electrons is this. Then the direction of current will be opposite to the direction of electrons. Okay, now this is the current. Now the conclusion is that when potential difference is applied across the terminals, here current is flowing through the conductor. Now what is the relation between the applied potential and current flowing through the conductor? Okay, when let this potential difference is increased, so here on the positive phase, here the positive charge will be increased. Okay, positive charge will be increased means the attraction force on the free electrons will also increase. When the attraction force will increase, here if attraction force is more, then electron revolving in the interior orbit of the atom will also experience some attractive force towards the positive phase. Okay, and if the attraction of this nucleus is less than that of this attraction force, then this electron will also removed from the atom, detached from the atom. Now and same process will be for all atoms. So in this conductor, the number of electrons are increased. When the number of electrons are increased means the charge particles are increased. Charge particles are increased means this Q is increased. When Q is increased, I will also increase because I is directly proportional to Q. So when potential difference is increased, current flowing through the conductor also increases. Okay, if the potential difference again increased, then the current flowing through the conductor will also be increased. So what is the relation between potential difference and current? Okay, now to understand this, the firstly German scientist George Simon Ohm studied that he took a conductor and with the battery, conductor is connected with the battery. This is the this end is connected to the positive and this is connected to the negative, and he joined a emitter in the series with the conductor, and he also joined the voltmeter with the conductor in parallel. Okay, now this is for measuring the current flowing through the conductor, and this is for measuring the potential difference between two ends of the conductor. Okay, and he studied that when he increased the potential difference across the terminals with this battery, then he saw that current also increased. Now again he increased the potential, current also increased, and he saw a relation between potential difference and the current, that when potential difference we discussing about the numerical values, if he would have taken 1 volt of the potential difference, then he would have seen that the current flowing through the conductor is 2 ampere. Okay, and if he would have increased the value of potential by 2 volt, then he would have seen that the current flowing through the conductor was 4 ampere. Okay, now when he would have taken the value of potential difference by 3 volt, then he would have seen that the current flowing through the conductor was 6 ampere. This is the example for understanding us. So what is the relation here? When 1 volt is increased here, in 1 volt current is 2 ampere. Here 1 volt is increased. Here 1 volt potential increased. So in increasing 1 volt potential, here what is the difference between the current in first reading and second reading? Here 4 minus 2 equal 2. For here 1. And what is the difference here? 3 minus 2, 1. And what is the difference between the current? Here 6 minus 4 means 2. Okay. In each experiment, in each observation, he saw that the ratio of potential and current is directly proportional to each other. Means in the same ratio, when potential difference is increased, then the current flowing through the conductor also increases in the same ratio. For 1 volt, potential current 2 ampere. In another 1 volt, here current is 2 ampere also, means conclusion is that the current flowing through the conductor increased in the same ratio of the potential difference applied across the two terminals. Okay, and he reached in a conclusion that the potential difference, current flowing through the conductor, is directly proportional to the potential difference applied across the terminals of the conductor. So this is called the Ohm's law. Okay, why? Because this relation relation is studied or discovered by the German scientist George Simon Ohm. Okay, that's why this relation is called Ohm's law. Okay, now it can be written as V equal R into I. So this R is here proportionality constant. Okay, and this R, this proportionality constant, is called resistance of the conductor. Okay, we will discuss about the resistance of conductor later. So this equation can be written as R equal V upon I. Okay, this is the constant, means for each observation the ratio of V and I should be same. He observed many observations, many readings, and he reached that if about this experiment, about this observations, if V equal 1, so R will be first 1 volt upon current 2, 0.5, and next reading voltage 2, then current 4, here 0.5. Third reading R3, voltage 3 and current 6, means 0.5. This value, this value, this value, these values are same for each observations. Okay, means this value is constant for each observation. That's why this is called the constant. Okay, this is called resistance of the conductor. We will discuss about this later.